way a language is defined is in the syntax of that language itself. The way Rebel is built, how the interpreter is built, it's constantly using itself. It's using its own language technology to build the next level of itself. It bootstraps itself at every level. And in terms of software engineering, that leads to an enormous difference in complexity. And exactly the problem that several of us want to address. And you can do it different ways. Norman is now going to talk about Gnode, and Gnode is very much about doing an operating system framework the right way in C and C++ and having an integrated project and making no mistakes. And that's also what Syllable Desktop is about. It's about making a classic traditional system with C kernel and C++ graphical user land and doing it well. And that's usually a losing proposition, because that's going to lose in the market because you're taking longer. So the only way I see to maybe address that, you probably have to wait for an evolutionary bottleneck, you probably have to wait for disasters before you can offer people something better. But the other way, the only way that you have a fighting chance to break that trend is by having such a language that enables you to write things and invent things that other languages simply can't do. You can invent things in Rebel that you wouldn't write in C++ because it's just, it doesn't fit into your brain. The limiting factor here is the human brain. And there are very, very, very many connections inside the brain that once you have to talk to the guy next to you, even if you're your closest friends, then there are suddenly all those connections between those brains are an extremely small bandwidth. So the more you can keep in one brain, the more you can do. And if you use C++, Syllable people are going to hate me if they see this movie and see me saying this. In C++, you can, with a team of a few people, you can get Syllable in your head. But to get a Lotus Notes equivalent in your head and all the stuff that's on the internet now and stuff that Google is doing with different projects in different languages, if you want to get that into one head or a few heads, a perfect project team where communication doesn't explode because there's only a few people, you can't change your brain. A little. IQ is rising across the century, but very, very slowly. The thing we can change is software. And the fundamental thing to change is computer languages. And this is a very good way to do that. They're also efficient, in complexity. But that means that because domain-specific languages are defined in Rebel itself, there's no disconnect. And it's efficient because you're using the same underlying evaluation engine for everything. There's no impedance mismatch. And there's a huge advantage in tools because if you write a tool that will work on Rebel code, it will work on all dialects of Rebel. Those that exist now and those that will be invented in the future. And maybe a certain tool will be less useful for future dialects, but you can still evaluate the entire pool of tools for Rebel because they all work on that standardized lexical level. And I have to say that Boron is almost compatible at the lexical level, but there are a few differences, so that's annoying. I don't like it because that's a break between Rebel and Boron, but they're small, so it's not a big problem at this moment.
Mijn time is up. Thanks.
Gaan we naar Gnode?
Sorry, misschien even goed om te zeggen.
Ja.
Het begint allemaal een half uurtje later.
Ja, I know, but
Dus,
I have other responsibilities.
Oké, ja.
Okay.
Nee, maar ook voor anderen.
I think you have a good introduction.
I think I do, so we'll talk later.
The first slide was for you.
Yeah, I know.
So you have a good overview.
Have you got contact details, Jurgen, or just mail me? Or?
And there's the website of the
Yeah.
Pixel. Nice meeting you. Thanks.
Rascal is quite like this actually.
Yeah, I think so.
Yeah.
Six. Well, we'll talk more later.
Great, thanks.
But to be clear to the others, the presentations are shifted a quarter to half an hour.
So G-Node, when is G-Node starting?
When you're ready.
Okay.
How much more slides do you have?
10?
Whoa.
I'll do it a bit faster.
Try to do another quarter and then
Yeah,
stop.
because the rest is about building the simple website, and that's applying these principles.
Okay.
And the principles are most important. So this is the thing. We're going as an example to see what this is very theoretical and philosophical even. So for regular people to see what you can really do with this, and how you can see that you can do quite a bit with very little work and very little code. The example is building a small website. And it's actually this website. I'm going to show how this presentation here is built in Boron itself. So it's really applied. So if you get the philosophy and you believe that you can build a website with it in a few hours, then you're free to go. So that's the rest. So I'll go through it further. It's far faster because it's not as fundamental. So if you make a parts list of what you need for a small website, this is about it. And it really looks fairly intimidating already if you've never done it before. And I actually took many years before I started building things like this, because you have to put too many things together. You need a web server. Well, we're running on the Cheyenne server, which is written in Rebel. So that's taken care of. It's a Boron presentation, so we need Boron to do the website in Boron. And I've said because domain-specific languages are really modeling. You're modeling a problem domain. And that's where you get the huge boost, because if you can do modeling of a problem domain, you're not working at the abstraction level of the hardware machine. You're working at the abstraction level of the user. You're working at the abstraction level of your customer. And that's a huge difference. So what you want is to do modeling. That's a hot trend the past 10 years or so I shouldn't have to explain that. But the point is, one fundamental way to do modeling is with domain-specific languages. And I've just tried to defend that Boron is very much designed to make domain-specific languages. So, in modern terms, it's very much designed to do modeling. Only when Rebel was designed, they didn't call it that yet. So we're going to actually model a simple website, because that's the goal of the entire philosophy. You have to get as close to the abstraction level of the problem domain, and as far away from the bits and bytes in the computer. So we want a model for the content that you want on a page, and then of course you have multiple pages, so you need a database for pages. But database is usually a huge thing, so we're going to see how you can do it much simpler if you don't need that much. Eventually it needs to be a web page, so you need to somehow project the model of a page into an actual web page, and a very good way to do that is with a templating system. And we'll see that templating is actually built into Boron because it's fundamental. It doesn't say there's a templating system, it just does things that amount to templating. Well, you have multiple web pages coming from the multiple database, so you need a way to navigate through them. It's a presentation, so basically we only need to go forward, and if we need to go backward, we already have that support. So you need a very simple navigation framework for going to the next page. And we want to show some meter programming, so we want to see